Go ahead.
Hey. Hi, everyone. We are Reprise, the Developing and Prototyping Honeypots group. I'm Kalkadan Bahailu.
I'm Angel Huang.
I'm Luca Lorena.
And I'm Anna Zhu. Before we really get into the weeds of our project, I just wanted to give y'all a brief overview of the higher level objective. The goal of our project is just to create a honeypot that emulates a virtual private network server, also known as a VPN server. Honeypots are a cybersecurity tool, and cybersecurity is such a crucial part of the internet in today's day and age. Just to give you guys an idea of how important it is, Duke currently blocks about 1.5 billion malicious connections per day, according to a 2019 Data Plus project. And the reason why we wanted to create a honeypot that specifically mimics VPN servers is because VPNs are so commonly used nowadays. They can be used across a variety of different settings, from professional environments to group projects to one's own personal projects, which makes them a common target for cyber criminals to attack. And Duke Networks currently does not house any VPN honeypots, so our group wanted to fill this gap by developing our own. I'm sure a lot of you guys are wondering what exactly is a honeypot. But honeypots are essentially just devices that serve as decoy systems, and they work by attracting potential attackers, allowing security teams to detect, monitor, and analyze the activity of cyber criminals without risking any real data or systems. Since the honeypots simply act as decoys, there's no important or essential data connected to our servers. Therefore, there's nothing that a cyber attacker could really extract from connecting to our honeypot servers. And then once a cyber attacker connects to our honeypot server, we will then be able to track their IP address, their geolocation, the time and duration of the attack, and sometimes even the username password combinations that they try to log into a network with, which can be really useful. And then from there, we can block these cyber criminals from the Duke network. Some examples of common honeypots that we are currently running on the Duke network include Cowrie and Dianea. These are just like other honeypots that emulate different servers and different websites. But our VPN honeypot, we decided to name Kala after our team's initials. So like K, Cal, Anna, Luca, and Angel. And then the second part of our project is kind of the VPN aspect. So we are emulating our honeypot after VPN, which I mentioned earlier stands for virtual private network. But basically VPNs work by providing encrypted connections for users across the internet. It works by creating like an encrypted tunnel between the user's device and then the server itself. And then therefore you can start to send encrypted packets along this tunnel. And it just acts as an intermediary between a user's device and the internet. And there's a lot of different types of VPN protocols. And we did a lot of research into this when we were first starting out, because we wanted to kind of figure out what was in the market, what kind of VPN protocols we wanted to mimic our honeypot after. So some popular ones just include like OpenVPN, PPTP, etc. Our honeypot specifically currently supports WireGuard and then IKE version 1 and version 2.
Okay, so our honeypot is going to be hosted on Stinger, which is just an abbreviation for Shared Threat Intelligence for Network Gatekeeping and Automated Response. It's a honeypot platform owned by the parent company ForeWarned, which actually has its roots here at Duke. It's the largest shared cyber threat platform in higher education, and it's used by over 80 colleges nationwide. Of course, here at Duke, but also at Stanford, Brown, Columbia, and many other colleges as well. So before we really got into the brunt of building our honeypot, we started out by learning a little bit about hacking tools that both cyber criminals and penetration testers alike use. We mainly focused on three, being Wireshark, Metasploit, and Nmap. So I'm going to go break down each of these one by one. So the first tool we're going to talk about is Wireshark, which is a type of packet sniffer, which basically means that it's used to capture and analyze network traffic, with a packet being like a piece of data that's transferred between devices on a network. And it can be used to detect suspicious activity and discover hacking attempts. The next tool we're going to talk about is Metasploit, which can be used to test network and device security by simulating attacks. For example, you can simulate a denial of service attack to test if a network can withstand such kind of attack. It helps identify vulnerabilities before real hackers can find and exploit them. And it's often used with the last tool we're going to talk about, being Nmap. Okay, so the last tool we're going to talk about is Nmap, which is used to discover computers and services on a network It can help detect unauthorized devices and services, and it's often used alongside Metasploit, like I mentioned before. So this is our tech stack, which is the majority of the software that we use to create our honeypot. Our honeypot was written completely in Python. We used Docker to create a separate application environment to run our honeypot in. We used WireGuard and StrongSwan to test our honeypot's connectivity. Ubuntu Linux to run a virtual machine on which we ran our honeypot, since we did have a few problems running our honeypot on our native OS, which we'll talk about later on, and then Fluent to transfer the data from the honeypot to the external Stinger servers.
Okay, I bet everyone's wondering the $1 million question. How did we build Kala, our VPN honeypot? Like Anna mentioned previously, Kala does stand for, it's an acronym of all of our initials. So Cal, Anna, Luca, Angel, Kala. So first things first, we have to code the honeypot. Because we only had 10 weeks, it wasn't feasible to create the honeypot from scratch, like completely from scratch. So we got our open source code framework from GitHub. So looking for a framework, we wanted to make sure that the framework supported connections and utilized multiple commonly used VPN protocols. And then once we had that framework, we were able to build upon it, making sure that it suited both ours and Stinger's needs. Our honeypot utilizes TCP and UDP. So TCP and UDP packets are networking protocols that allow devices to communicate using data packets. It just allows devices to communicate. And then two, it allows for connections through IKE v1 and v2, which stands for Internet Key Exchange version 1 and version 2, as well as WireGuard. Our honeypot was created and runs in a Docker container. A Docker container is like a small, lightweight package that holds everything an application needs to run. So that includes the code, library, settings, all of that fun stuff. And that this ensures that app works the same in every single environment, whether that be my laptop, my teammate's laptop, a virtual machine, all the environments. And then this is a feature that comes very handy once we encounter some of our setbacks, which I'll talk about in a little bit. And then lastly, Docker containers are isolated from one another and the host system, which allows it to be efficient and secure for all of us creating it as well. As we were building Kala, we faced a couple of setbacks. The first being a port usage conflict. Our entire team has MacBooks, so we all have an Apple environment. This became an issue because we wanted our honeypot to use port 4500 and port 5000 for the IKE v1 and v2 connections. However, we weren't able to connect to the honeypot using port 5000. Turns out Apple AirPlay was port 5000, and we just didn't know about that. So we had to switch from working on our personal Apple environments to working in a virtual machine that utilized Ubuntu Linux. And then this is where having the Docker container really, really helpful, because the app works the same everywhere in a Docker container. We were able to seamlessly continue working on the application or on Kala as we switched to our VMs. And then as we tested our honeypot connectivity, like the second thing that we had to do was, once that we had everything built and working, was to make sure that we tested honeypot connectivity. We used two VPN clients, so StrongSwan and WireGuard. We used StrongSwan to connect using the Internet Key Exchange version 1 and version 2 protocols, and then we used WireGuard to connect using the WireGuard protocol. When connecting using StrongSwan, we didn't really have any setbacks, which was a great success on our end. We did that. On the other hand, when connecting with WireGuard, we had some small setbacks that we encountered. One being that we wanted WireGuard to connect using port 9000, which we quickly found was not accessible. This was a quick fix though, because all we needed to do was edit the code in our Docker file to specifically tell WireGuard to connect using port 9000. However, once we got everything fully connected and working with WireGuard, we had another issue. Our WireGuard logs were flooding the screen. So essentially, WireGuard uses UDP communication protocols, which are UDP packets are very, very lightweight. And so they're the fastest way for devices to communicate on a network. So at this point, our honeypot was logging every single packet that was being sent. So imagine the amount of flooding that we were getting. The honeypot was logging every single packet. UDP packets are the fastest thing to be transferred or to be sent. So it was logging everything and quickly flooded our entire screens. We weren't able to really comprehend what was going on, what was being logged, or even read what was being logged, since it was going so fast. So Because of this, we had to find a solution, multi-level logging, which Amy will continue to talk about next.
Yeah, thank you, Cal. So as Cal said, we did have that problem with the logs flooding our screen. And so again, after building the honeypot and seeing what happened when we connected to it, then we could actually begin modifying it. And so I was kind of in charge of coding the honeypot to better suit our needs, which involved creating that logging system. And so we came to that solution, which was multi-level logging, which just meant that we have 3 different levels. One was the most basic. It would only print out the most important information. And then the last level, level 3, was the most verbose. And you can see here with level 1, in the picture, you can see that you only get the sender index and then the IP address and source port from the client, and then also the destination IP and port. And for level 2, this is just in between 1 and 3. So level 2 would log the level 1 logs, as well as if you're creating a VPN session and some packet requests, as well as more client info. And you can see in the photo here, under creating VPN session, there's more information about the client. And then lastly, level 3, of course, is both level 1 and 2, and then it'll just print every single request and response and all the client information. So this essentially was flooding the screen, but we wanted to keep that level of verbosity because after talking with our sponsor, Cisco, they wanted us to log as much information as we could because that's the best way to see what the cyber attacker is doing, who they are. And so the multi-level logging system really was a good solution for that because you could still see the logs, but also control how much information you could see. And so after implementing the logging system, this also involved getting the honeypot connected to the Stinger server. And so to do this, I kind of added output modules into the code to support FluentBit and FluentD, which are just logging services. So since the honeypot is built in a Docker container, we basically want the container for FluentBit as well. And so you have the honeypot in a container as well as the FluentBit container, and these two are essentially the honeypot. And so the FluentBit container will connect to FluentD outside of this, envelope. And FluentD will allow it to connect the logs to the Stinger server, and we'll be able to see the logs on Stinger. So we are still working on this aspect currently. And so fingers crossed, we can get it working in the near future. And for future plans, we do want to add other VPN protocols. So talking with Cisco, our sponsor, the most common protocol that they use is SSL, or Secure Sockets Layer. And so we want to see if in the future we could add that to our honeypot, as well as any other VPN protocols. And lastly, we do want to try creating a VPN session using the IKE protocols, because even though we were connecting using StrongSwan, that third-party VPN client, we weren't actually able to create a VPN session. We were just able to touch it, kind of make that initial connection. And so maybe in the future, we could figure that out and see what happens when we actually create a VPN session. So now we have a little video of how to use our honeypot. So you can see here that I'm just composing the Docker container. And then after it's up, I'm going to run the WireGuard command. And you can see that this is for level 1. So it's only printing the most basic information, just the IP addresses and ports. And then for level 2, I'm going to go into my Docker compose file and change the variable to be level 2. And after I save that file, I can recompose the container. And then after I compose it, I'll just rerun that WireGuard command. And again, for level 2, you get more information. So you see there that there's level 1 plus that extra client information as well. And then for level 3, same deal. You just change the level to be set to 3, and then again, run that WireGuard command. And you can see here that you'll get literally every single log. So it's really fast. And again, this is mimicking that original logging system where it just shows everything. So yeah, as you can see, this honeypot does log a lot of data, and it is very easy to change the settings. So that's where we currently are with our VPN honeypot, Kala.
And then we don't want to finish presenting without making sure that we thank everyone involved in helping us. So one, that's Hugh Thomas, our team lead, and Eric Hope, our team lead. Thank you so much, as well as Alex Merck, our mentor. And then we have our program directors, Isabel and Jen. Thank you as well. And our program facilitators, Jalen and Miriam. And then last, most definitely not least, our project sponsor, Cisco. Thank you all so much. And does anyone have any questions?